Hello everyone, welcome to Spectra Education and myself Dr. Rajeshwar Panja. As you all know that we are discussing about the mathematical physics for B.Sc Physics Honors course basically, and this is the part of core course 1, but from now on I will make the videos in English language basically because some of my students asked me to make that one because they cannot understand the Bengali language, but don't worry, I will make the videos in very easy language with deep concept, but where you need the critical need to understand the critical concepts, then I will also use the Hindi and the Bengali language to make it clear. Okay, but one thing I would like to say in Bengali for my students কি যদি তোমাদের বাংলাতে প্রপার বাংলাতে একদম যদি লেকচার সিরিজ বানাতে হয় তাহলে আমাকে অবশ্যই জানিও, আমি আলাদা করে বাংলাতেও সেম লেকচার সিরিজ বানিয়ে দেব. So let's start with today's lecture. What we have discussed earlier, let's summarize it. We have started to discuss about the vector calculus basically, and in vector calculus we are discussing the vector differentiation. We have already discussed about the concept of gradient and the steps how to solve the problem regarding the gradients, and in the last video lecture we have discussed about the divergence of a vector field and what its physical meaning we have already discussed, and what is the mathematical definition and what is the mathematical symbol of divergence we have already discussed in last video lecture. In this video lecture I will discuss about how to solve the problems, basically I will discuss about the steps, and following these steps we will be able to solve any problem regarding the divergence. Okay, so basically I will discuss 4 steps to solve the problem which is based on the divergence, and in this lecture also I will discuss about the curl of a vector field, its physical meaning and its mathematical definition, and again the steps to solve the problem related to the curl of the vector field. So let's start with the divergence of a vector field and what are the steps to solve the problems. So first let's summarize what is the divergence of a vector field. Divergence of a vector field, it basically gives you an idea, is there any spread of a vector field or not. Spread means it could be spread from a point or all the vectors are going towards a points, both of them under the divergence problem of a vector field. And if we find out that the divergence, what is the mathematical symbol for divergence? For example, if V is a vector field, what will be the divergence or how to write the divergence of a vector field mathematically? Then we have to take the nebula vector dot with this V vector. It is known as the divergence of the vector field V. If we found out that divergence of V is equal to 0, then what information we can get from there? It says that there is no source or sinks at the particular point. As we have discussed in the earlier video that whenever we are talking about the divergence of a vector field, that means if I consider this is a vector field, that means at each and every point we can find out a vector But when we are going to find out the divergence of the vector field, we will choose a particular point, let's say this point A. So at that point we would like to know, is this vector field is spreading or shrinking? Okay, so divergence is a point dependent things, right? So if at any point, let's say at that point, after mathematically solving this problem, if we find out that divergence is 0, then at that point we can infer that there is no source or sink. If it gives us a positive value, that is +1, +2, +3, +4, any number, then we can say there are source. Okay, and it is also for a particular point, let's say point B. And if it is negative value, so then we can say there are sink. One thing I would like to say here, that if for a particular point, at any point, let's say at that point P, if we find out that divergence of this vector field is equal to 0, then this vector field is known as solenoidal. क्या बोलते इसको? Solenoidal. What it means? যদি কোনো একটা পার্টিকুলার পয়েন্টে ডাইভারজেন্স যদি 0 হয়ে যায়, রেজাল্ট যদি 0 দেয়, so then we say at that point this vector field is known as the solenoidal vector field. Okay, so let's start to discuss about the steps to solve the problems. For let's begin with an example. So let's example 1. A vector field, let's say this is the vector field V. It is given x square I cap plus y square j cap plus z square k cap. Okay, this vector field is given and it is asked that at the point 1, 0, 1, what is the divergence of this vector field? Is there any divergence or not? It is asked. So how to solve that problem? So what is the impact of this point? It means if we consider the Cartesian coordinate system, so this is x axis, this is y axis, and this is z axis. So where is this point 1, 0, 1? So along the x axis move 1 unit, along the y axis it is 0, that means we will not move along this direction. So and then you have to move along the z axis 1 unit. So this point which is in this plane, that is in this plane, xz plane, this point is 1, 0 and 1, right? So at that point you would like to know, is there any spreading or shrinking of this vector field or not, or is there any source or sink at that vector field or not. Okay, that means this space, this three-dimensional space, maybe it is filled with lots of vectors which makes this vector field V. If you want to plot this vector field, let me know. I will teach you how to plot the vector fields in graph paper. Okay, so for that moment, this is our problem. At that point, is there any divergence of the vector field or not? So what is the step 1? First step 1, first write down the expression of this nabla vector. Okay, so expression of this nabla vector, as you all know, that it is I cap del del x plus j cap del del y plus k cap del del z. Then in steps 2, first 2 to 3 problems, follow these steps. Later on you will be able to solve the problem directly. That means you can follow only the 4th step directly. So in the steps 2, write down the given expression of the vector field, which is nothing but x square I cap plus y square j cap plus z square k cap. And in the step 3, do the dot product, that is divergence of V directly here. So what it means, write down this one, that is I cap del del x plus j cap del del y plus k cap del del z. This is the expression for nabla, which is dotted with the vector field, that is x square I cap plus y square j cap plus z square k cap. Now as you all know, this is simple vector dot product, so I cap will be dotted with this I cap. So that means this first term, that is this del del x, will only operate on the first term. When this del del x will operate on the second term and the third term, it gives you 0. So dot product is very simple, as you all know that one. So I cap will be dotted with I cap, it gives you 1, and del del x will be operated on this x square. So we can write this one as del del x will be operated only the first term x square, because I cap is here and I cap is here. In the second term, that is, here is the j cap. Where is the j cap? Here at the second term. So del del y basically will only operate on this y square term. So this is the rule of dot product, del del y square plus, and this del del z similarly, because here is the k cap and here is also k cap, so they will find the same relatives, right? So del del z will operate on the z square. Now it is very simple, it is the partial differentiation del del x of x square, because only x term is there, so we can think it is like a ordinary differentiation. So it gives you 2x, and the second term give you the differentiation to y, and the third term gives you the differentiation of 2z, right? So this is the step 3, but it is asked that what will be the divergence, is there any divergence at that point? So this is the crucial step, that is the step 4, S4, where you have to find out this divergence of V at the point 1, 0 and 1 point. 1, 0 and 1 point means x is equal to 1, y is equal to 0 and z is equal to 1. So this is the divergence, this is the expression of the divergence of V. So in this expression, if you just insert this x is equal to 1, y is equal to 0 and z is equal to 1, then you will get your result. So let's do it. So 2 into 1, x is equal to 1, plus 2 into y is equal to 0, plus 2 into 1. So what is the value? It is 2 plus 2, that is 4. So 4 is a positive number. So that means at this point, if we take any other color, so at that point what we have found out? We have found out that the divergence is a positive quantity. So that means from there, if it is asked what is the physical meaning of that expression, that at that point there must be some source, or we can say that net outward flow of this vector field at that point is positive, or we can say the outward flow is greater than the inward flow. Okay, so this is the physical meaning of that problem, and the divergence problem is very easy. So later on, as I said in the previous lecture, in these few lectures I will discuss about the basic concept of the gradient, divergence and curl, and I will only focus about the steps by which you can solve the problems. Later on in some videos I will discuss different types of problems, from simple to complex problems for gradient, divergence and curl. I will teach you how to solve any problem from that part. Okay, so that's all for the divergence related discussion, and in the next video I will discuss about the curl of a vector field, and in this curl of a vector field I will discuss the physical meaning and what are the steps to solve the problem. And later on in 2 to 3 lectures I will discuss all types of problems regarding gradient, divergence and curl. So that's all for the day. I have taken I think a little bit much time to explain slowly the concept and the solution steps. So we will meet again in the next video. If you have any suggestion or any question, you can write the comment box. If you need the lecture series in any language like Hindi or Bengali, I can make also in these 2 languages also. So see you again. for that moment by